We are going to do a little review before your quiz today. And I'm going to use page 92 in your books because a lot of these are similar. A lot of these practice problems from 2.2b are similar to the questions that you'll see on your quiz. I'm also going to go over the practice from 2.2c. I know some of you were able to get your stamps by checking the answer key with the sub, but I want to go over how I got those answers so that you guys can see how I did all that before you take the quiz. I think this will help. So on page 92, that's where I'm at, page 92, we have just a few questions. I mean, this is not a long assignment. I've got the first one that says, explain how you know these two figures are similar. Okay, and this goes back to what we've been trying to get all week, which is a better understanding of what it does mean for two shapes to be similar. We know that congruent means everything's the same, right? But similar, they don't necessarily have to have the same side lengths. We found out that they can have the same side lengths, but they don't have to. If I have a dilation, those shapes are similar. And we can see that's what happened here. These two are not the same shape. And then when you look closely, the side lengths are definitely not. You see that they're listed. They're not the same. So let's go ahead and say what we would need to prove that these two figures are similar. First things first, you guys found this out way back on Monday. The angles are the same. The angles have to be the same. So I'm going to put that down first. The angles have to be the same. The angles have to be the same. Okay, we had that with congruence when two shapes are congruent, but that's also true for similar shapes. Okay, the angles have to be the same. They also have to be the same shape. Let's start off by saying that. I could have a square that has four 90-degree angles, and I could have a rectangle that has four 90-degree angles. Just because the angles are the same doesn't mean the two shapes are similar, right? So let's say that it has to be the same shape. Has to be the same shape. And then the last thing that we figured out on Tuesday was that the scale factor has to be the same all the way around. Okay, you can't have, we found this out in our activity from Tuesday, you can't have some of the sides of the shape use one scale factor and then the other sides of that shape use a different scale factor. Like that's not how dilations work, right? When you dilate something, it has to be the same scale factor for all the sides. So let's put that down, that the scale factor is the same for all sides. And let's actually figure out what that is. Let's put a little comma there because we're going to finish off that sentence with what the scale factor actually is. The scale factor is the same for all sides, comma, and then we'll say what that scale factor is. So how do I find scale factor? Okay, this was a big part of 7th grade. Remember, scale factor is the new measurements divided by the old measurements. So which shape here is the new one and which one is the old one? This one, it doesn't matter. Okay? There's no missing sides. There's nothing I have to figure out. So you guys can decide which one is the new and which one is the original. I'm going to say this one's the original just because I read from left to right. So this is the first one I see on the left. So that is the original one and that this is the new one. And if my scale factor is new divided by old, that would mean I've got to take 4.5 and divide that by 6, or I could take 3 and divide it by 4. Either way, right? I'll get the same answer either way because it's supposed to be the same scale factor for all of the sides. Well, 4.5 divided by 6 is 0.75. 3 divided by 4 is 0.75. So I did just prove that it is the same scale factor all the way around. Okay, so I'll put over here 0.75. So the scale factor to go from that original shape to the larger shape to the smaller shape is 0.75, which that makes sense. Remember, if a scale factor is less than 1, that makes the shape smaller, okay? You could go the other way. Like, let's say you didn't know that that one was the original one. Let's move this. Let's move this over here. Let's say this is the original one. And let's say this is the new one over here. Okay? Let me fix that so it's in the middle. If that's the case, then your scale factor is just flipped. Instead of 4.5 over 6, it's 6 over 4.5. Instead of 3 over 4, it's 4 over 3. But in that case, you would get, so I'll put or, whoops, I'll put or here, just for the scale factor part. Or 4 over 3 is the same thing as 1.3 repeating. Okay. If you thought it was this way, the way I have it written out now, where the original shape is the smaller one. Okay. All right. Enough with that one. Let's go on to number 2. I'm going to leave that there. I'm actually going to circle that in blue just so we can come back to it later here. So for this one, it says quadrilateral ABCD is similar to quadrilateral GHEF. So them telling us that it's similar, we know that has to have the same scale factor for all of the sides, right? So what they have here is they've given us this side length, H to G, and this side length, whoops, A to D. Those are the corresponding side lengths. So those are the ones that I would use to find the scale factor. This is the original, and I know it's the old one or the original because it has all the measurements. We know all the measurements for that one, and it's on the left, so I always read from left to right. Knowing that that's the original one, I'm going to find my scale factor by doing new divided by old, so it's 9 divided by 6. And that equals 1.5. Now that I have the scale factor, I can multiply all the original measurements by that scale factor to get the new measurements. Okay? So I'll erase these circles so they're kind of out of the way. This looks a little cleaner. Now that's all I'm doing. To find this measurement here from G to F, I have to multiply A and D together. Or A and D, that length, 7, by the scale factor, 1.5. 7 times 1.5 is 10.5. And then do the same thing for all the other sides. The other short side, this one here, 5, that's going to correspond to this side. So 5 times 1.5, or 1.5, is 7.5. And then finally, the last side, 10. 10 times 1.5 is 15. Now I can answer the question. The question is not what are all the missing side lengths, but what's the perimeter? Well, we know perimeter, you just add up all the sides. 9 plus 10.5 plus 7.5 plus 15, that gives me 42. Okay, and another one with scale factor. By now, hopefully scale factor is ingrained in your brain. That was most of 7th grade, and now we're reviewing it again. It's saying that they're similar. Triangles X and Y are similar. Find the scale factor listed below. So if it's telling you which one is the original, by which one they list first. It says from triangle Y to triangle X. So Y is the original, and it's changing to X. X is the new one. So let's scroll up. Scale factor right there, new divided by old. If they're saying X is the new one, that means I'm doing 10 divided by 15. Now the second question reverses it. It says, what about from X to Y? So you just flip your scale factor. It's 15 divided by 10. If it switches directions and says that X is the original and Y is the new. Okay? When you do those divisions, 10 divided by 15, that simplifies down to 2/3 or 0.6 repeating. And then 15 divided by 10 is equal to 1.5. Sorry. 1.5. Okay. All right. With the sub, you guys watch the video on this. But I want to go over how I got these answers. So I know some of you got your stamps from the sub. This is just using scale factor, but in a different way. And I'll show you what I mean here in a minute. What you guys found is actually the third way to prove that two shapes are similar. If you can divide the side lengths of each shape and get the same answer, that means they're similar, right? So what I mean by that is, here's C, right? Here's C on this triangle. C is in the same position as 9 on this triangle. Here's D, this horizontal length right here on the triangle. Well, D is the same thing as this 7.5 on this small triangle. So it says these two are similar, and what you found out in the lesson is that if you divide the side lengths on one of the similar shapes, that's going to give you the same answer as if you would have divided the corresponding sides on the bigger shape or on the other shape. So if I want to know what C and D are, or C divided by D is, I don't have to know what C is. I don't have to know what D is. It's going to equal the same thing as 9 divided by 7.5. Because 9 and C are in the same position. D and 7.5 are in the same position. So I just have to figure out what 9 divided by 7.5 is. 9 divided by 7.5 just happens to be, hopefully what the sub told you, or what he checked off, 1.2. Okay. For this one, it says these two triangles are similar. What are A and B? Not. It says not. It's supposed to say note. The figures are not drawn to scale. So one thing I do want to point out, and you could always use your patty paper for this, but if you trace this out, sometimes it's hard to tell which side goes with which. But if you trace it out, you can then take your patty paper and rotate it so it's facing the same way. Whoops, I made that a little bit larger. There we go. That way it's easier to tell. I forgot to write down all the numbers that go with it, but this one was the 4, this one was the 9, and this one was A. Okay, but now I can see right away, okay, I have this side and this side. These two corresponding sides, I know both their measurements. So that's going to help me find the scale factor. I need to know the scale factor in order to figure out these missing side lengths. So let's do that. Okay, my scale factor, let's say this big shape was my original shape and this was my new. I would do new divided by old. We wrote that down on the other page. New divided by old means 4 divided by 10. Well, 4 divided by 10 is 0.4. So to get A, I'm going to take the side that corresponds with A and just multiply it by the scale factor, 15 times 0.4. Well, 15 times 0.4, shouldn't have to look this up, but I am, it was 6. You should have gotten 6 for that. Okay, and then do the same thing to find B, right? Except, let me erase all this. B is on the original shape. So I'm not going to multiply with the scale factor because I know the new. I know what the measurement is on the new one. What I need to do is work backwards to figure out what the measurement on the original shape is. I'm going to have to divide. I have to divide 9 by 0.4. 9 divided by 0.4 is 22.5 or 22.5. And that makes sense. I mean, when you look, B is on the larger of the two triangles. I should have a bigger number there because that's the longest side. So that 22.5, that fits. And you know, if you would have done 9 times 0.4, you know, you would have gotten a small number. You would have gotten actually 3.6. That's not right. You know, there's no way that long side there is 3.6. So we divide 9 by 0.4, that's what we get is 22.5. And then finally, number 3 here, it says, here's triangle ABC. triangle XYZ, which we don't have, is similar to ABC with a scale factor of 1/4, which means, remember, you use all the original side lengths, 1/4 of them. So I know to find 1/4 what I thought was easiest for this, and you guys could have done this easily with patty paper, is cut each length in half and then split each half in half, right? Each one of those little sections now is 1/4. And do the same thing for this one. Cut it in half and then cut it in each half in half. Each one of those is 1/4. I think I need to move this one down a little bit. There we go. And then the same thing for the last side. Split it in half first and then split each half in half. Okay. And again, I think I need to move this down just a little bit. Okay. All right. And it doesn't matter which corner you take it from, but you'll get 1/4 of it no matter what. You know, if I start from point C up here, if I start from point C up here and just connect those, there we go. There's a triangle that's 1/4 of the original triangle. I could have done that from here. Nope, iPad. This one, we don't want the magic of the iPad to help us because it's not working out. There we go. Yeah, well, the iPad kind of messed me up there, but you get the idea. Or I could have taken it from this corner. Okay, each of those are the same thing, right? If I had a way to make them all be in the same position, you would notice that they all kind of match up. Okay, looks like the iPad kind of took this point out a little bit. It should be more this way. But you get the idea. It is the same triangle for each of those. Okay, and then you would just draw that off to the side. Oh, actually, I think, you know what? I think I can. Yes, take it off to the side. So there we go. There's triangle XYZ. So X, Y, Z. How do the angle measures compare? Well, we know this. We learned this last week. Dilations don't change the angles. The angles are the same. The angles are the same. And then I'm going to put in there, explain how you know dilations don't change angle size. Okay. The letter C there, what are the three side lengths of triangle XYZ? Well, if triangle XYZ was formed by using a scale factor of 1/4, I just have to multiply all of those by 1/4. Okay, it doesn't matter which one you start with. I'll start on the base here. If I do 4 times 1/4, it's 1. And then do the other side. I'll do this more vertical side. If I do 5 times 1/4, it's 1.25. And then for this more diagonal side, if I do 7 times 1/4, it would give me 1.75. Okay. Then, this is what the lesson was having you do. It says for triangle XYZ, calculate the long side divided by the medium side, and then compare that to the same calculation from triangle ABC. So if I do that, if I do the long side divided by the medium side for this triangle and for this triangle, we know what should happen. We should get the same answer. All right, let's check it and see. The long side for triangle XYZ is 1.75. The medium side is 1.25. So I'm doing 1.75 divided by 1.25. For ABC, that's 7 divided by 5. So I punch that into my calculator here. 1.75 divided by 1.25, I get 1.4. If I do that for triangle ABC, 7 divided by 5, I get 1.4. Okay, so, you know, they are the Same. Which, that's what's supposed to happen. That means that they truly are similar triangles, similar figures, okay? All right, so we are actually going to take the quiz now. You guys are going to take the quiz now. Lesson 2.2D does not get on this quiz. So you're going to take the quiz because it's just over 2.2A, B, and C. Lesson 2.2D actually fits better with next week's quiz. So you'll see that lesson get quizzed next week. So you're going to take the quiz now. You're going to end this video here in just a second. Don't end it yet. You're going to end this quiz and end this video in just a second. Go click on the quiz. Go to Canvas. Click on LG 2.2. Or click on Unit 2, click on LG 2.2. The quiz is at the bottom of the page. The password for this is what I am today. Absent, okay? Once you're finished with the quiz, hit submit. The level 4 is on the quiz there. You guys can use your books, okay? Make sure your phones are in your backpacks. Make sure your backpacks are on the front wall. And then after you're finished with the quiz, level 4, like I said, is on the Canvas quiz itself. You don't have to have a separate sheet of paper. There is no separate sheet of paper. Hit submit and then watch the LG 2.2 video. Okay? We'll take care of all stamps next week. And that's it. Best of luck to you.